Video we're going to develop a Dolphin Smalltalk Raylib application. So this video can serve as a tutorial for Dolphin Smalltalk, my Raylib bindings, game development in general, and the Smalltalk programming language. So the first thing we need to do is install Dolphin Smalltalk. So if you type Dolphin Smalltalk JIT into Google, you can go to the Dolphin Smalltalk repo. You want to go to the main repo, core image repo. And you want to follow these instructions here. You can skip the building the virtual machine and just there's a way you can download the VM, otherwise you can build it. If you don't want to go through those steps, it's not that difficult. You can go to releases and you can get the Dolphin 7 setup executable file, but you'll be a little bit behind the JIT repo. The second thing you want to do is go to Dolphin Smalltalk Raylib. And you can see my Reddit post is linked here, so you go to my JIT repo and go ahead and clone my JIT repo, and you'll see this folder once you clone my JIT repo. And so what we need to do is put the image, the Dolphin image, in my JIT repo folder. So I'm going to go ahead and open Dolphin. So here's Dolphin Smalltalk 7.2. We're going to save the image as, and I'm going to go ahead and put it in my JIT repo folder. So we've got our image here. I'm going to set up my environment here. I'm going to open up 2 idea spaces. Open up the package manager, 2 code browsers in the workspace. 2 code browsers on the right. Okay, so we go to packages, install package, and we can just install Raylib examples. That will pull in the main Raylib package as well. Now let's look at the Raylib package. So we have our Raylib library here. You can see the file name is Raylib. So the first thing we're going to need to do is you can either build the Raylib DLL with the changes I've made. I've only changed 3 lines of code. Or you can go to this resources folder in my repo and just copy the raylib.dll. I've already built it. It's a 32-bit MSVC DLL with the changes I've made. So I'm going to copy that DLL into the main folder. And let's look at the Raylib library class. You can see the Raylib functions are implemented here. And if you look at the Raylib cheat sheet, these are all the Raylib methods. So you can see all these beginning ones I've got implemented. So you see here void init window, width, height, and constant char string to title. You can see we've got a init window here. So we're going to be sending messages to this library class, instance of the class. So in my Raylib examples package, I've got Raylib demo, which we can start our application. We can subclass. So what we're going to do here is create a new package. This will be the package we work off of, and we'll just call it space game. And we'll save it as space game. And then we're going to create a new class. And what we'll do here is just go to the Raylib examples, Raylib demo, go to new. And we'll type in space game. And we're going to package it in our space game package. So now we've got our space game class. And to start the Raylib demo, you can see these methods, start demo windowed in the class side, start demo full screen. And the windowed res here is what the windowed resolution will be. Otherwise, full screen will go to your full screen and it'll make a borderless window. So I've set the windowed res to 1024 by 768. That'll give us plenty of room to keep developing while the game's running. So let's just try running this real quick. We'll run start demo full screen. And I recommend you save the image before you actually run Raylib, just in case anything goes wrong. So here is Raylib running at about 3,000 to 4,000 FPS with nothing really happening. And let's look at this Raylib demo function. So we have when you call start demo, it sets this full screen bool and calls run. So run gets called, and then we initialize the Raylib library to this RL variable. You can see RL is a variable here, and then we just set a Raylib color Raylib. You can see in the Raylib function we've got these external structures, which are all Raylib specific structures, and we've got color Raylib is one of them. So we just set the RGB values here, and we make a white color, then we make a light gray color. We set should terminate to false. We create a random number generator, and then we call init window setup, and then we run the main loop. And as long as should terminate is false, the main loop will keep running. If you push escape in the application, should terminate will become true. So you can see in main loop, it closes the window if window should close, and then it calls process input, process logic, and render. So in process input we have nothing, process logic we have nothing, and in render right now you have to call RL begin drawing and then RL end drawing, and we just clear the background to white, and then we draw the FPS, and these are all Raylib methods, and that's how the demo gets rendered. So what we need to do is, first of all, we're gonna override this render method. And we'll just copy this code here from Raylib demo. We need to actually clear the background to a black color, so I'm going to make a black color variable, and we'll put this in setup. So we'll override setup here. We'll call super setup just in case something needs to be done, and we'll say black color becomes color. Actually, I'm going to copy the template from run here. So we'll make black color, and we'll make all these values 0. Okay, so now I've got a black color, and then in render we're going to clear background to black color, and we will save the package, and we should have a, I'm actually going to copy in these methods here just to make it easier, and then I'll save the package and save the image, and then run it, and we should have a black window. Yeah. So the next thing we're going to need to do is create some classes for the objects in the game. So we're going to make a game object class, and we're going to give it variables position, velocity, and rotation. And we're going to create accessors for those variables, and I'll just make them public. Although it doesn't really matter in Smalltalk, it doesn't matter if you call a private method. It's just for developer support. And in our space game, in our setup, we'll create a new asteroid. So we'll say we actually need to create a collection for the asteroids and the bullets. Okay, we need to subclass game object. We'll make an asteroid class and a bullet class. And we'll make a player class. So in our Raylib demo, in our setup, we're going to set asteroids to be a new ordered collection. That's just an index collection. That's very common. And bullets will be an ordered collection. And then we've got the player object. And so what we're going to do here is say asteroids add, asteroid new, and we're going to say position becomes 500 at 500. We're going to chain these messages. Velocity becomes 0.1 at 0. That's just a little bit of rightwards movement. And rotation will be 0. And we'll send yourself to the new object. So now we'll be creating a new asteroid when the application starts. And what we need to do here is initialize the game object. We'll make an initialize method. We'll just set everything to default values, rotation, and velocity becomes 0 at 0. This will just stop some debugger calls if they're not defined. And we'll override new with answer super new initialize, so our initialize method always gets called. And so now we should be creating a new asteroid object, but it obviously isn't being displayed yet because we haven't loaded any textures. And now I'm going to show you the files in resources. We've got the asteroids images here, and we're going to use asteroids 2x, so I'm going to open this. So this is the main image we're going to use. You can see we've got these big asteroids here. We're going to use those right away. And then there's this cutting guide image, which just shows you the size of the images in the sprite sheet. So these are 160 by 160. So first we need to load the texture. So we're going to go into our space game and our setup method. And in the bunny mark demo, this is being done. So we'll check out setup here. And we've got this line right here. So we're just going to go ahead and copy that. And we'll make a asteroids texture variable. Okay. Oops. Okay, and then we're going to rename this to asteroids texture. And it just basically RL is a Raylib library. Load texture gets called, and then you send a string. So we want to get the name of that file, which is asteroids2x.png. And copy that. And we send it as parameter. Now when my library is more complete, you won't have to send as parameter, but right now I think this is necessary. We should be loading the texture here. And now we can load in our render method. We can draw the texture. So I'm going to take out this draw FPS. And we're going to iterate over all the asteroids. So we're going to say asteroids do each. And this is how you iterate over a collection. You just say do, and then each instance of the collection will become each as it goes through. So we're going to say each. We're going to say RL draw texture pro. And draw texture pro is a method in the Raylib library. Let's search for it here. You can see it takes in a texture, a rectangle source, rectangle depth, a vector to origin, float rotation, and a color. So the color should just be white color because we don't want to add any tint to the image. The texture 2D will be the asteroids texture. And now we need a rectangle source, a rectangle depth, and a vector2 origin. So the source is actually where in the texture it's drawing from. It's a rectangle. And we need to use the Raylib rectangle, not the Dolphin rectangle. So we look in the Raylib library here. We see we have a rectangle Raylib external structure here. And it has these methods on it. So let's make some variables here. Rectangle source, rectangle depth, and vector origin. So we'll say rectangle source becomes what is it? Rectangle Raylib new. And then we'll set the dimensions. X will be 0. We're actually, if we look at the image here, we want to start at this upper left-hand corner and draw 160, 160. So we'll say X is 0. We'll chain these messages in. Y is 0. And then width will be 160 because that's the size of the asteroid, and height 160. And then we'll throw in yourself just to make sure. So there's our rectangle source, and for some reason we have a problem here. We're expecting a... Oh, actually I don't need an end parentheses there. Okay, so let's just put rectangle source in there. And then rectangle depth will be about the same, just where we want to draw it. So rectangle depth is where on the Raylib window we want to draw what we've sourced. You can make it bigger or smaller than the source, but we're just going to put it at each position X. This will be the position of the asteroid, each position Y, and we want it to be also be 160, 160. And then we need to make a Raylib vector 2, so it's right here, vector 2. So we'll say vector origin becomes vector 2 new X. We're actually going to make it 80. And the origin is where in the rectangle source you want the center of the image to be drawn. So we take the width divided by 2 and the height divided by 2 of the texture, and that'll just center the texture right there. And so we put this vector 2 origin in. Vector origin. And then rotation, we want to use each rotation. So that should be good. We'll save the package, save our image, and try the demo. Okay, and it didn't work. Let's just see if we're doing everything right here. Okay, I'm actually just going to save the image and reload it. That might be the reason. Okay, so there's our asteroid. Now let's add a little bit of movement to it. Let's go to setup here and... Okay, so it has a little bit of velocity. Let's go into game object and let's make an update method. Update movement, and we'll say position becomes position plus velocity. That will update, actually change position of the object when this is called. So in our space game we need a process logic method, and we'll say asteroids do each update movement, and we'll just save that. And now the asteroid should move. Yeah, there we go. Okay, so we have a moving asteroid. Now let's add our player object. For the player, we want a different image, so we want one of these images. Let's look at the cutting guide. So we want this image right here with no thrust. So we need to go 160 down, 96 down, and then we need to go 64 plus 64 plus 64, and then we'll be at this area, and it's 96 by 64. So we need to update the render method. Let me just keep this open here. So we'll say RL draw texture pro. Okay, so the source will again be the asteroid's texture. Now the rectangle source is going to be a little bit different. I'm going to make a variable up here. Player rectangle source, player rectangle dest, and player vector, player center. Okay, so let's go ahead and copy this. So player rectangle source. Now we want to go down. Let me use a calculator here. We want to go down 160 plus 96 equals 256. So y will be 256. And then for x, we need to go over 64 plus 64 plus 64. So 64 times 392. And then width and height, width will be 96. And height will be 64. Okay, so we'll put this in here. I will copy this. And for the dest, we're going to use player position X, player position Y, width and height, we'll just put 96 and 64, that'll be fine. We have an undeclared player for some reason. Yeah, we never made a player variable. Okay, and then finally we have player rectangle center. Player center equals vector 2 new x. We're going to go 96 divided by 2. Y will be 64 divided by 2. And save yourself. Okay. And then rotation will be player rotation. The color, of course, is white color. So let's go ahead and reform and accept that. And we need to set up the player, so we will player becomes player new, position, make it 200 at 200. rotation 0 and velocity 0 at 0. Not sure why this is a problem. Player. Okay, we'll save that and see if the player shows up. Okay, so apparently it is drawing the player, but it's drawing from the wrong part of the image. So let's check the image here. So it's drawing one of these these big asteroids. So we went down 160 and we went down 96. I'm not sure why it's drawing that. So yeah, it's drawing this one actually. Our x variable is wrong or something. And our y variable. So let's make sure that these are right. Okay, yeah, the player rectangle source is completely wrong. I'm not sure how that happened. So yeah, we need to go down 160 plus 96. So y should be 256. And x should be 64 times 3. 192. I must have put the wrong variables in. So let's save that. Okay, so now we have the player. Now let's add rotation to the player. Let's actually add some variables here. So let's add is thrusting, is rotating right, and is rotating left. And let's create accessors for those. Not sure why those variables don't show. Okay, here we go. Let's create accessors for these variables. And then an update movement. Okay, we'll actually set the rotation in the process logic of the space game. So we need to call the functions for input. So you'll see in the Raylib examples in the bunny mark demo, we have some function here. So we have our is mouse button down. So actually what we need to do is look in the method Raylib library, and we look at is key down, or yeah, is key down. So in our space game, Arl is key down, and then we need to find out the virtual key code. So I'm just gonna Jacob from the future here. Actually, I had some problem with the virtual key codes. Turns out that Raylib uses the GLFW key codes and not the normal key codes. I'll show you how you can check those. If you go to the Raylib GitHub, you just go into source and raylib.h. If we go key up, you can see these are the key codes. So it's 265 for key up. And I've added some to these pool dictionaries. So we have Raylib constants pool dictionary. So we've got key down, key left, key right, key up. And we just got to make sure that those pool dictionaries are referenced in our code. So we go to Raylib examples, Raylib demo, and this should be in the JIT, but I'm going to go ahead and add it now. So Raylib constants. Save that. And now we can use the constants, so we can go into our space game, process logic, and these are the key codes that I tried using and didn't work at all. So we can go key up, this is left, key left. And those constants just substitute the number when it's called. So in case I cut off some of the code, you can see I basically just added these if true methods. So we do RL is key down, key left, if true. And then player is rotating left is true, player is rotating right is true. I put a halt in here, I'm going to get rid of that. So after doing that, we'll save the package, save the image, and try the demo. Okay, if this happens to you and the DLL can't be found, just terminate, save the image, close the image. This happens the first time you put the image in the folder and you don't open it again. So I'm going to open it up again and it should work. Actually, I forgot to copy the DLL, sorry. Okay, so now it should work. Let's just save the image and let's try the demo. So now if we push right arrow key, we start rotating. But you can see it doesn't really work very well. It stopped rotating, so let me check in my player object. In update movements. So yeah, I'm not sure if I covered this, but in update movement, we put in is rotating right. If true, rotation becomes rotation plus self-rotation speed. And then I have rotation speed is 0.1, so put that method in. I covered this before, but I actually lost the video and then I had to recover it, but so in update movement, we need to set all the variables back to false. So is rotating right becomes false, is rotating left becomes false, is thrusting becomes false. And now we should have working rotation. So yeah, we can rotate, everything's looking good. And now we want to add thrust to our player. So basically I'm just going to ask ChatGPT for a thrust method. Write me a Smalltalk. Write me some Smalltalk code that applies a thrust So let's just see what ChatGPT spits out here. It's kind of ridiculous, but this is the code we need here. Let's just copy that. And let's go into the input. So we're going to go here to is thrusting if true. Let's copy this code in. Let's make a variable for the thrust vector. Let's just make thrust magnitude. Actually, let's make a method for it. So And rotation. We'll change these so they use the proper Smalltalk methods. And finally we need a thrust magnitude. I'm not sure what it should be, but I'll just answer 0.01. Hopefully that'll be the right scale. And let's see what happens. It probably isn't going to work right away, but we can fix it. We're not getting any movement here, so let me bump up the thrust magnitude. Let's bump that up to 1 just so we can see if there's any movement. Okay. So yeah, we didn't actually add the magnitude to our position, our velocity vector, so we have thrust vector here, and we go velocity becomes velocity plus thrust vector. So actually, let's debug this and just see what we get. I'm gonna halt here and run the game. So we have a breakpoint, and let's see what we get here. I'm going to step over this, and we have thrust vector is nil. Well, it's because it isn't thrusting. So let's actually just display this. Okay, so it did add the thrust vector, so it should work. I'll take out the halt and we'll test it. Okay, we need to make sure this goes in the if true block. Okay, let's continue that. Okay, so obviously we're going off the screen now. Let's reduce the thrust magnitude to 0.01. Save the package, save the image, and run the game. Okay, so it's going straight down. So what we need to do is change the rotation that gets sent in that code 90 degrees to the right. So in update movement, let's just ask ChatGPT. Not sure that's gonna work, but we can try it. We just changed the sine and cosine. See if that actually does something. And let's lower the thrust magnitude even further by a scale of 10. And let's run the game. Okay, so now we have rotation in the correct direction. We still are thrusting too much. So let's just really bump this down by 2 orders of magnitude. And let's try it. Okay. So yeah, apparently it's not working. I think it's because we're expecting radians or something, and Raylib is expecting probably degrees. So let's check the Raylib documentation, or actually no, it's not Raylib. Let's just see what we're doing here. So we can do a little debugging here. Let's start the game first. And I'm going to rotate the object so it's facing up. And what I want to do is check the rotation. So I'm going to go into player, update movement. And I'm just going to self-halt. Need to actually accept this. If you push Control S and the game is running, it doesn't work, so you have to use the mouse. So we have a breakpoint, and we have process logic, we have update movement. So the rotation is -90 degrees. And maybe that's messing with the rotation. So let's ask ChatGPT if he can help us. Okay, so apparently we need to rotate, normalize the rotation. This obviously isn't correct. So let's see what we get on the thrust vector here. So we get a weird number. Yeah, this is using exponential notation. That's so small, but I feel like the thrust vector is just wrong because let's check the Smalltalk source to see if cos uses degrees or radians. Yeah, it's an angle in radians, so we need to convert from radians to degrees. So let's see if Smalltalk has a radian to degree, rad to radian. Yeah, we have radians to degrees, so we'll go ahead and put that in. So we'll say radians to degrees and rotation radians to degrees. Send. Let's see if that fixes it. Still running the game actually. In a breakpoint. So let's Let's resume this. Let's take out the halt. Let's resume this. Okay, the game closed now. Let's make sure that code is correct. Okay, we're not, yeah. So there's a few things I can try here. Okay, so actually rotation is in degrees. So let's do this. Let's see if this fixes it. Okay, we're going way too fast now. Yeah. So we are thrusting to the right, but if we thrust up, it's just not working in some aspects. Okay, this looks like it might work. Let's just copy this code. Okay, now we're just barely moving, but it looks like it's actually working. Okay, yeah, so it works now. You can see how I use ChatGPT to get some programming help. It's actually pretty useful. So now we have movement, and we have an asteroid. So now we need to be able to fire bullets. So when the spacebar is pushed, we can add a new bullet. So we need to go to update movement, or actually let's go to process logic. Let's make a fire bullet method. Fire bullet Okay, and then what we're gonna do is actually, we're not gonna do this here. Sorry. Let's delete that. Okay, so in space game, in process logic, we're gonna check for spacebar. And we need the virtual key code for spacebar. Which is 32. And eventually I'll have all these key codes set. So we can just put 32 in here. Put it in the comment. And then we need to, we'll just say self fire bullets. And we'll make the fire bullets method. Okay, bullet becomes bullet new. Actually, we're going to make a variable. And bullets add bullet. And then we need to set the position of the bullet to the player, so bullet position becomes player position. Okay. And we need to add some forward movement to the bullets, so let's look at how we made a thrust vector. Let's copy that code. Look at the player rotation. We can delete this, and what we need to do is let's get a bullet thrust magnitude. So let's make a bullet thrust magnitude. Let's see what we had for player. Okay, it's this. So we want it to go a little bit faster, so we're gonna delete a few zeros. Let's just delete it by an order of 10. Magnitude of 10. Order of magnitude. Okay, so fire bullets. So self bullet thrust magnitude. And the rotation. Okay. And then we'll take the bullet. Velocity becomes bullet velocity plus thrust vector. That should move the bullet when fired. Okay. Now let's make sure that the bullets are being updated in process logic. We just need this. Okay, and now it should actually work. Okay, we're not rendering bullets, so we need to render it. Okay, this code down here doesn't need to be here. And we need to see if we have a bullet in the asteroids image. So yeah, it looks like we do have some bullets. So these are 32 by 32 each. So we need to go down, so these will be 16 for each grid. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 9, or 18. So let's get our calculator up. So 16 pixels times 18 equals 288. Width is 32. And the Y is, I forgot what I said. I think I said 288, so the Y is 288. Now we need to check the X, and it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28. So let's get our calculator, and 28 times 16 equals 448. Okay, so now we should theoretically be drawing a bullet. That's not good. We lost our player ship. Let's check our render method. Yeah, something went wrong here. Oh, we actually removed. Okay, so what you can do in this case is go to browse other change history and restore the code. You can go back to earlier versions of the method. We actually do need this. Okay, so let's copy that in. Let's save. And let's save the image and run the game. So we'll push spacebar. Okay, there's our bullet. It is moving very slow, but it needs to move a lot faster than that. But also, the image is completely wrong. Okay, we're basically going really slow, so I'm gonna up the magnitudes. Let's up this a couple orders of magnitude. I'm not sure why that happened. Now ideally, if you're programming a game, you want to use delta for your updates in logic, but yeah, so this might run at a different speed depending on what FPS you're running at. So you can set the FPS in Raylib if you want it to be the same, or you can use a delta, but I'm not going to cover that. Okay, so we're firing too many bullets. That's a problem. Yeah, we're firing like hundreds of bullets every time I hold space. So what we need to do is actually not call is key down, but we need is key pressed. And that will only do it once. Raylib library does not understand is key pressed. Now let's check the Raylib cheat sheet. So there is an is key pressed method, but I don't have it implemented in my library. So I'll show you how you can implement a function if it's not implemented. So the first thing I'm going to do is just try to recover from this error, and I'm just going to comment out this code and then resume. Okay, so we're good. Close that. And now what we need to do is implement the method in the library. So we go to Raylib library. Let's look for is key down. Okay, so we're just gonna change. We're gonna add a method is key pressed, and all we have to really do is just change it to the name of the method, which we can see in the cheat sheet. Make sure that it returns a bool. Here's a bool. And in key st word. This should all work, so we can just save that, and then we've added to the Raylib library. And now it should theoretically work once we take out the comments. Okay, so we have bullets. Great, and we're going too fast. Yeah, I don't know why the speed seems to be changing, but apparently I do need the player to be a lot slower. Not sure why this is happening. Let's see what it's like. Okay, so we're good. Now, if you were making this game, you probably want to spawn these bullets in the front of the player ship. Should be easy to do, but I'm not going to do it. I'm just going to make a simple example, not a complete one. So what we need is collision with the asteroids. And then once the asteroid collides, we need to split it up into smaller asteroids. So first, let's just check if the player collides with the asteroid so we can kill the player. So we need collision detection. I'm just going to ask ChatGPT. Write some collision detection in Smalltalk. Each object will have an extent and see if it is colliding. So first we're going to add an extent to our game objects. Extent. And so in our initialize methods, actually let's just make a method. So in bullet we'll make a new method called extent, and we'll answer 32 at 32. In player, I'm just going to answer 64 at 64. I know the player is actually shaped differently, but it'll work. And bullets and asteroid. And I think this one was 128 by 128. Let me just check that real quick. 160 by 160. So now let's see what ChatGPT spit out. Is colliding with another object. So we can go ahead and copy this. And we'll take game object, new method, is colliding with another object. Okay, so this might actually work. So we've got this collision detection, and in the update movement of the objects of the player, actually will say okay, so we'll say, yeah, I don't know why the tabs are different, but so we say self, or no, we'll go through all the asteroids, so we'll go asteroids, or actually we can't do that because the asteroids are in space game. So we need to make this in space game. So we'll go process logic. We'll put this in the asteroids code where we iterate over the asteroids. And then we'll say each is colliding with player. If true, we'll just reset the position of the player position. We'll just set it to 0, 0. And now theoretically we have working collision detection. Let's add some more asteroids. Let's give it some negative velocity, negative 0.01, so we can definitely hit it. Let's save that, and let's run it. Okay, so let's collide with the asteroid. Okay, so the collision works. And now we need to do the same for the bullets, so... So really we need to check it with each bullet. So each asteroid will check it. And we'll say bullets, bullets do, bullet. And we'll say bullet is colliding with each. If true, we'll remove the asteroid. So we'll say asteroids remove each. That might work. Not sure if that's the right way to use an ordered collection, but I'll save the image. And okay, so now if I fire a bullet at it, yep, okay, good. And the next things we could do is break up the asteroid into multiple smaller images when it collides, etc. But I think that's enough for this demo, just to see how to make a game with my Dolphin Smalltalk library. And if you have any questions or comments, please leave them in the YouTube comments. And thank you very much for watching. Goodbye.